Find pretty big numbers.
I forgot the new number I got. I used to be one, but I forgot that.
You know what? He just took it. I know 2 and 3 both work. There you go. I have a list, but it's buried on my desk. I'll sort it all out for us next week. I just want to point out to everybody that I have been here every day this week. Woot, woot. That's a big deal. I'm finally starting to recover, I think, from COVID. Last night, my husband and I looked at each other and we were like, we're still awake. Usually we're watching TV going, I know. I was like, wow, maybe we're actually getting over this. Now I spoke too soon. Monday I'll be like, oh my God. All right, here we go. So let's reduce it. 4 over 52. You can reduce it just by putting in your calculator 4 divided by 52. Math, enter, enter. What'd you get? 1 over 13. 1 over 13, right? If you hit 4 divided by 52 and hit math, enter, enter, it should reduce to 1/13. It doesn't occur here, but you can also do what I call cross-canceling. Like if you had a number that would cancel here and here, or here and here, you could do that too. It would make it smaller. Now, how do we multiply fractions? Remember? It's just top times top, bottom times bottom. So 1 times 1 is 1, and then just do 13 times 13. Thank you. Now, if that would reduce, which it doesn't, but if it would, then you keep going. So the probability that you reach in, pull out 1 card, get an ace, put it back in, shuffle it back up, reach in, pull out another ace is 1 out of every 169 times. So it's pretty rare that you're going to just get 2 aces. Not that you couldn't, just not a very high probability. Okay, so this one, 2 cards to be selected without replacement, again, from a deck of cards. Is that not the exact same thing? Oh, that one was with, oh yeah, okay, just kidding. So same problem, only this time we're not going to replace the ace. So what I would write down is I would write down without replacement. And probability of ace and ace. Okay, so again, just like before, probability of the first ace. Arthur, how many aces are in a deck of cards? 4. So that's 4 out of 52 times. Now for the second one, this one's a little, not tricky, but we have to think about it. It's without replacement. So we take the ace out for the first one, but we don't put it back in. So now, how many aces are there? 3. So our top number is going to be 3. You'll still need that calculator for this stuff. And if we took that ace out, Angelo, how many cards are in the deck? If we took the first ace out?
51.
51. So it's a little different when it's without replacement because I have to lower it. Okay, now again, I want to reduce these. So 4 over 52 we found was 1 over 13. In your calculator, or you can do it without it, hit 3 divided by 51 math, enter, enter, and it'll reduce that for you. Double check and make sure you can get that, y'all. Make sure you can figure out how to get it. And so we do top times top, bottom times bottom. What'd you get, Angela?
1 over 221.
Yep. So a little harder to get it because you have less aces now when you don't replace that first one. Okay, here's another definition. I think this is the second definition we've had, maybe 3. Independent events. Neither event affects the probability of the other event. Anytime the problem is with replacement, then they're independent events. So that very first example was independent. So if they ask you if it's independent events, just see if it's with or without replacement. And if it's with replacement, it's automatically independent events. I would write this down because you're going to need this when we have a study guide, probably in our homework, just in general. So obviously we're just going to read through this and then we'll jot down what we need to. There's 100 people attending a dinner to recognize the accomplishments of a local citizen. 3 people in attendance will be selected at random and will be awarded 1 door prize. You cannot win more than 1 door prize. So basically, if you get 1 door prize, then you're not up for the second door prize. Are the events of selecting the 3 people independent or dependent? So our real question is this with replacement or, without replacement. If it's with replacement, then once they picked your name out of the hat and you got the door prize, say you got the first door prize, then with replacement means that you would put it back in. But this says you cannot win more than one door prize. So if I pick Mardarius out of the hat, I wouldn't put his name back in. So that means it's going to be without replacement. So then when we look back up here, independent events were with replacement. So that means that this example, since it's without, must be dependent.